So JISC is a company that supports all of further education and higher education to be, make the most of digital technology. And one of the products that it provides is the Janet network. Janet and the Janet network has been around for just over 30 years. Came into being in 1984, so one of the very early sort of networks. It was brought into being to connect the main sort of computing centres at that time and regional sort of scientific networks. And it used a protocol called X25 at the time, and it used X25 for many years until the early 90s, and one of the first IP connections from the US was brought into Janet by a professor at the University College of London. And for about 6 months or so we ran IP tunnelled over X25, and there were a few dinosaurs in the company at that time saying IP will never take off. But quite a few progressive people, and very rapidly IP became the dominant sort of protocol. And Janet grew from there. It is the first data centre directly connected to the network, and the first shared data centre as well. As this one takes off, we do envisage the requirement for further data centres, potentially for a second data that's located in the north of England. So we've got that geographical diversity. And geography still is, it's very early days, it is still a bit of a barrier to universities. They've moved from a position of housing the equipment on campus, and often people administering that equipment and the researchers like to physically see that equipment and be able to touch it and so on. But with the latest generation of computing equipment, it's more and more reliable. It's often very resilient, so if blades do go down, there's the spare capacity that takes over, and you have a maintenance contract with the manufacturer who can replace those blades very quickly. So I think gone are the days where you need your computer systems very close to you. So we're trying to, I think that culture change is going to take a little while to get over.
If it's here on site, it's going to be really, really fast. There's not going to be any lag and all this sort of stuff. I mean, online gamers and all the rest of it, no, the further they are away from the game they're trying to play, the more lag they get and the slower the response. How do you deal with that?
Yeah, Janet is a very high capacity, very fast network. So we engineer it so that there isn't any congestion on the network. As a sort of, you might experience as a home user of the internet, whether it's watching Netflix or whatever, the occasional sort of pause in the film. With Janet, we ensure we have enough capacity to cope with peak loads, so there isn't congestion. And that means that whether it's sort of large data transfers or somebody doing a very interactive sort of simulation, they get the performance they need out of the network, so that geography then isn't a barrier.
So what sort of tests have you done? Can you put a number on any of those things, or is that too...
So the actual delay somebody would experience, or in fact not experience, if you're a researcher at Glasgow University wanting to get access to your data in Slough here. So the round trip time going from Glasgow to Slough back to Glasgow is 12 milliseconds. So to put that into perspective, if you were having a phone call over the internet, so if you were using something like Skype, you wouldn't notice any perceptible delay, beyond or less than 50 milliseconds. So the 12 milliseconds really is sort of negligible. The network's designed not only to sort of carry traffic generated by students from their workstations, but also to support high-end data-intensive research. So whether it's the sort of particle physicists doing sort of work on the CERN experiment, through to radio astronomers doing their work, through to very recently the sort of biomedical research, which has really sort of started to generate huge amounts of data. And that data typically needs to be moved from where it's being generated, the experiment, to some high performance computing or to some storage which might be geographically distant. So we have to support a whole range of requirements. So you need very high capacity networks. So the latest iteration of Janet, we have acquired 6,500 kilometres of optical fibre, and that covers the whole of the UK. And fibre on its own, you can't just plug your computer into the fibre and away it goes. You need some very specialist optical networking equipment which lights that fibre and partitions that fibre into various sort of wavelengths in which you can inject your traffic into. And connected to that optical equipment, we put our internet routing equipment, and that gets located in various locations across the fibre network. So we have upwards of 47 locations just on the backbone where we have to put the optical and IP equipment. So those locations can be very small trackside cabinets, that's railway trackside cabinets, that house something called amplifiers, which amplify light on very long stretches of fibres, through to big data centres that we house our optical equipment in. And our network stretches from the southwest, Exeter, through to Edinburgh and Glasgow as well. And it does go further north, but we use different sort of technology to connect further north and further southwest as well.
Do these fibre optics run down the railway tracks?
They take a mixture of routes, so they can run down the railway tracks, they can go on the overhead power lines, they can run down canal side routes or motorways. So the fibre that we use, we work very closely with Scottish and Southern Electric Telecoms, and they themselves own a lot of fibre, but they also acquire a lot of fibre from other providers, and they aggregate all of that together for us, and so we have a single contract with SSE for a period of 15 years for that fibre infrastructure.
Fantastic. Okay, what else can you tell me about how that works then? I mean, it's obviously not always been fibre. I mean, how did it start out? Was it phone lines or? The very early computer networks were, you're right, just that it was copper infrastructure. But fibre has been around now for many years. Universities like the University of Southampton were very early pioneers in fibre technology and optical technology. So they contributed a lot to that research and introduction of the networks that we know today. So they were researching how that stuff works, and then obviously end users, I'm guessing, as well, obviously. That's
right, yes. The universities are end users. And in fact, we provide, there's a number of universities that do the specialist photonics research into networks in the UK, and we provide them with a dedicated optical fibre network that connects them up so they can experiment on the latest and next generation sort of optical networking equipment that'll power the internet in the future.
And so, I mean, we're here in Slough at the minute. Tell me a little bit about this. What are we doing here in Slough?
So, to JISC, Slough is very important. It's our first shared data centre. So we've partnered with Infinity, who own and operate and provide the data centre. and we've chosen Infinity because they run a state-of-the-art data centre. Most universities in the UK, they have a lot of computer systems to run either teaching and learning applications or HR or finance type applications through to some of the big research universities that use a lot of high performance computing. So they need data centres to house all of that equipment, and traditionally they've built those on campus. That's very expensive to run, and campuses and buildings on campus can more profitably be used for teaching and learning rather than for housing and cooling computer equipment. So our vision was to have 1 or 2 locations in the UK as shared data centres that universities can place this equipment in. They would typically be run very efficiently, the data centres, and because of the volume of equipment going in, the prices should be very, very keen, and that's exactly what we've achieved with Infinity. So the more universities put equipment in the data centre, the prices actually get lower and lower, and it's a far greener, more environmentally sort of friendly way of doing things as well. This is a very efficient data centre. The equipment that universities use will be purchased by the universities. At this stage, a lot of the universities that have moved into have got existing data centres, so they'll typically have 2 on campus, and many of them want to reduce that down to 1, and then initially have an off-site data centre. So they'll be busy decommissioning one of their on-site data centres and moving that existing equipment out into Infinity in Slough. There are a number of universities that have won large research grants very recently, and those research grants need to be supported by very high-end computing, which through those research grants they buy. So a lot of that computing is being moved into the data centre as well.
And is it a lot faster for them to commission that sort of a system then, if they just come here, rather than trying to build it?
Yeah, it's much more efficient. If you think about building a data centre on campus, you need to build it to a scale to accommodate sort of those research grants that you're going to win in the future. And initially, having an empty data centre being sort of powered and cooled is very inefficient. But if you're using somebody else's data centre, then from that institution's perspective, it's much more sort of cost effective. And in fact, with Infinity, the time between placing an order and being able to put your equipment in is a mere 4 weeks. Now that's very, very fast. It often takes sort of universities longer. Obviously, they have to place orders and so on. So commissioning things in the data centre, those 4 weeks is certainly not a barrier.